Okay. uh, Last week we discussed the change of base formula. The change of base formula. Okay. Under this change of base formula, what we really discussed, when we have a logarithm b to the base a, we learn how to write this logarithm using another new base. Okay. Now left hand side base is a. We told that we can write this left hand side logarithmic value this using a new base. Suppose the new base is c here, right? Then this term we can write, this b we write here, this a we write here. This way we said we can write this left hand side logarithmic expression using another new base c. This formula we proved. Okay, this formula we proved. Right, people. Now we can come to another few more laws we have to prove. Before proving them, today I supposed to do some question, right? Thereafter we go to that proof, and I supposed to finish all the proof today, so that next week onwards to do only the question. Understood? Right. Okay. Now, people take your tutorial. Take your tutorial. In your tutorial, page number 5, right? Page number 5. Question number 1. Page number 5, at the top you have a loss of logarithm. Just below that you have the question number 1. In that question number 1, let's do the first and second question. First and second question. Understood? So thereafter we'll go to the first part. Okay. Then under question number 1, first part. In the 1 part A, we are given a proof that 1 upon logarithm base 6 xyz, 1 upon logarithm base y xyz, 1 upon logarithm base z xyz. We have to prove this left hand side sum of these 3 log terms is equal to 1. Okay. Sum of these 3 log terms in the left hand side, we have to equal to 1. We have to prove that sum is equal to 1. That's what we have to prove here. Okay. Now, people, let's see how to prove this. Let's see how to prove this. Right? Let's see how to prove this. Okay. Now, I'm going to start from the left hand side. Left hand side, these 3 log terms, when we add, now we need to show their sum is 1. That's what we have to prove. Okay. Now, this proof I'm going to do this way. Last week, dear students, we discussed one logarithmic law. That logarithmic law is this. I think everybody can remember this. Okay. That law is this, people. When we have this way, log b to the base a, we proved this one we can write. Now, in the left hand side, this log term is available at the numerator. We proved, people, this log term, which is at the moment at the numerator, we can bring to denominator. We can bring to denominator. And you can write it as log changing these two values here A and here B. Now here we have 1. This way we proved one result last week. I think everybody can remember. No, we proved no this way. Yeah. Okay. This result, people, let's see how to use. Let's see how to use this result. The result we use like this, no? If a certain log term available at the numerator, you can write the same log term, take into denominator, exchanging these two values. Okay. Similarly, when we come from right to left, on the right, this log term available at the denominator. You can bring that to numerator and you can write it there also. These two figures we have to exchange. That's what this law says. People will apply that. We are here. Now what I do, for these three terms, equal terms I am going to write on the right. Now here this term, the log term available at the denominator. I am going to take that to numerator. Then these two values will change the places. Right. I am going to write that now. Then I can write log. This xy z comes to the place of base and x goes here. Right. Xy z and x comes here. What people now, when you take this to numerator, this xy z product comes as the base of the log, x goes here. Like that, the rest two terms in left hand side we can write using that law. Understood? Then this one also, when I take to here, we can write log, right? Xy z product here y. And this also I can take log. When you take this to numerator, this two exchange the places. Xy z z. I think everybody can understand this. Okay, now? Right. People now can remember next law I proved and we wrote another note. It is this. We did something like this. Second one. Can remember something like this we did. Log A, PQRS product. People, when we have a product like this, we told and we proved that we can write this product as the sum of log terms of this P, Q, R, and S. Can remember? We did that too. So I can write this as how log A P plus log A Q plus log A R plus log A S. These three people we got. I think we can remember that in the notebook available. Then when we have this way a product with log to the base A here, this product you can write this way. What are the converse results? If we have a product like this, sum like this, by this sum we can write the left hand side. How? Multiplying this number and writing log A here. People now the same situation here we have. Here this log term, the base xy z, here also xy z, here also xy z. The same base. And this log terms being added. Then this right hand side, right? When this right hand side has term, three terms, people, the same situation here we have. If the right hand side is like this, we can write the left hand side like this by multiplying this number. Okay. Then that result when we apply here, I can write the right hand side log xy z multiplying this number by reverse use of this formula. Understood? Now people just dig it. Now, the next one here to take this answer, you should know is this. People, you can see this. Look at this. You know, a equals a to the power 1. Now here we have, in the left hand side, this a, its index form only here we have. When you convert this to logarithmic form, I can write log this a I must write here, and the right hand side, this base, I must bring the base of log here. Then its answer going to be the right hand side power 1. I think everybody can understand this. The importance of this result is, people, see here, if this base of the log and the number of the log, if these two are equal, the value of the log term is 1. Value of the log term is 1. You can see here, people, here also, the base xyz, number also xyz. These two are equal. Then its log value should be what, people? Then answer is 1, no? So therefore, the answer should be 1. Now correct, no? Left hand side of this equal sign, we have sum of these three terms. Then sum of these three terms is equal to what? 1. Correct, no? That's what we have to do. See here, the way we use this formula we learned, the loss feeling, right? Okay, people, right? Then that is how we take that answer. Okay, right? People, we move to question number 1, page number 5 in your tutorial, part B. Question number 1, part B. Right. Take that, question number 1, part B. Question number 1, part B. You are given, prove that log here a b squared, that is within bracket, into log b c squared. We have to prove this is equal to 1/4 log a base c. This is what we have to prove. This is what we have to prove. Right? Now, when you consider this question, you can see left hand side, we have product of two log terms. Product of two log terms. Asking to show that product of this two log term, answer this. You can see on the right hand side in the answer, the base of the log is c. Base of the log is c. Then there we get a certain hint to take this answer. Writing this log term and this log term in the left hand side using the base c. Now here we have base b squared. Here we have base c squared. Now, since here the answer contains base c of this log, I suddenly got an idea to work out this question, converting this log term and this log term to the base c. To the base c. That means this base b squared and this base c squared of log term, we have to change to base c. You know, base of log we can change by using change of base formula. So I am now using, people, the change of base formula to this log term and this log term, introducing new base as C. What is the change of base formula we learned? It is this, no? If we have log B to the base A, that we can write how, people? On the right hand side, numerator and denominator both we have log. And the new base we supposed to introduce, we put here as the base of log. This left hand side, these two numbers, in the same way we bring to right and right at the numerator and denominator like this. Okay. This is the change of base formula. Right? Now I am going to apply that. Where? For this log term and this log term. Then I can write this. This log term I am going to write this way. I write log and log here. I am going to apply for this log term the change of base formula. Change of base formula. The base I am going to introduce is C. Why? Answer contains base C in the log term. Using that hint only, I started to work out this question this way. Yeah. So then I must write here C, here C. Then this A should be coming here. B squared should be coming here. Correct, no? Yeah. That is for the first log term. Second log term. Right. Here, I must write log and log. Base is C. C. On 2. Right. Now this B coming here. C squared coming here. Right. Now up to here, I think everybody can understand very easily. Now, people, can you remember we did another rule of logarithm? It is this. This also we proved last week. Logarithm base A, here M we have, that to the power R. Then we told people this power R you can bring before this log term, and you can write it how? R log base C M. This way we can write. Okay. The power here you can take before. Understood? Then using that, see here, the power of this B, 2, it is 2, no, you can take before this log term. And power of this C, this 2 also you can bring this before this log term. Understood? Now that's what we do next. See, once I bring that 2 here and this 2 here, I can write the next line like this. Here we have log A to the base C. This 2 comes here. Now 2 log B to the base C dot means multiplication. And here log B to the base C. Here also, people, this 2 I can bring before. 2 log C. I think up to here you could understand. Any question, dear student? Do you have any question? No. Right. Now see, here some simplifications can be done. What is first simplification? You know, here we have log B to the base C. The same log term we have above the line log B to the base C. These 2 are equal. This is above the line, right? This is below the line. Two equal numbers, right, people? If you assume this has 4, this also 4, that 4 and this 4 we can cancel down. Cancel. Then we can cancel down this way. This way. Now see here, 2 and 2 make 4. People look at this log term. Here, log C. Base is C, number also C. Are we told when the base and this number being equal, the log term gets the value 1. Here the space we wrote earlier. Base of log is A, number also A. The answer is 1. So therefore, this is really 1. This is equal to 1. This is equal to 1. Now, I can try the next line like this. The left-hand side, this product still we are having. Now I am writing, putting equal sign on the right-hand side. Okay. So then we have equal. On the left of this equal sign, people, this is available. If I need, I can write that. I'll write that. Okay. Log A base B squared, log B base C squared. Now here, 2 and 2 make 4, and here we have 1. Then 4 into 1 means it's 4. Understood? Right. So that is coming at the denominator like this 4. Now people, this 2 we cancel. No, after cancelling that we get 1 really. When you multiply anything by 1, it won't change. That is why we actually ignore this 1. It's also 1, no? Right. Now there we have numerator log e to the base c. This we have. People now, you know, dividing by 4 means what? Multiplying by 1 upon 4, no? See here. We divide 4 by 2. People ask this, 2 no? You know. I multiply this 4 by half. I multiply this 4 by half. Then cancelling this 2 and this 4. Again we get 2. So therefore, you can think here, dividing 4 by 2 means multiplying 4 by half. Like that, this log term divided by 4. Log term divided by 4 means multiplying this log term by what? 1 upon 4. Understood? So therefore, I can write the same thing like this. 1 upon 4 times log a to the base c. Then the answer we get, no? This is how people we use this law. Right. Right. Now understand and take the answer. Yeah. Next part is question number 1, part 3. Right. I received for question number 1, part 3. Okay. There you are given if log a divided by b minus c equals log b divided by c minus a equal log c divided by a minus b. Right. Then prove that ABC product is equal to 1 and a to the power a into b to the power b into c to the power c also 1. That's what we have to prove. Yeah. We are given people log A divided by B minus C. Here you can see in this log term, in the log term, dear students, no base is mentioned there. No base is mentioned there. Usually when the base is not mentioned, we of course take that as 10. But it is not important to mention their base 10 to take this answer. The reason is whatever the base of this log term, the all log terms available in the question have the same base. Now that base can be any value. Whichever the base this log term take, the answers we can prove. So therefore, don't worry about the base of this log term. Okay, right. So we can assume that base has 10. No, any other value which is not equal to 1 and which is positive. Because you know when we write the log term, the base should always be a positive value which is not equal to 1. That we learned at the very beginning of such value there can be as the base of this log term in the given question. So therefore, don't worry about the base of this log terms in the question available, right? So then people, this is equal to again given log B divided by C minus A equals log C divided by A minus B. Now we are given when this log A divided by B minus C, that answer is equal to log B divided by C minus A, that answer equal to log C divided by A minus B, that answer. People usually this way when we have a numerator and denominator, it is called as a fraction. It is called as a fraction. Then here we have this is a fraction, this is a fraction, this is also a fraction. We have 3 fractions, people. These 3 fractions are equal. That's what we are given. Now I'll take this 3 fractions half. 3 by 6, 4 by 8. People, this fraction, these 3 fractions you can see, these 3 fractions are equal. Do you agree with me? These 3 fractions are equal. Why? Reason, if I really consider this half means people 1 we divide by 2. People, we know when we divide 1 by 2, we get 0.5. So therefore, this answer 0.5. Here, 3 divided by 6. 3 divided by 6. This fraction means people 3 divided by 6. That answer also 0.5. Okay. Here, 4 divided by 8. When you divide 4 by 8, that answer is 0.5. You can see the answer of each fraction 0.5. That is why people, we could write this fraction equal to this fraction equal to this fraction. For each fraction, when we consider separately and find the value of each fraction being the same. The same. Like that, people, these 3 fractions are equal because of when we consider individually each fraction, the answer each fraction has, right, the same. That means all these fractions have what common answer as over there 0.5. Common answer. That is why these two fractions are equal. Then I am going to use people, I am going to think that common answer each fraction has as k. As here 0.5, I am going to assume that as k. Understood? So then we start like that. We can write starting like that. Let this divided by this equals this divided by this equals this divided by this equals k. K. Right? No matter, because why? This equals this equals what? 0.5. This 0.5 only people here we assume that's k. So, you know. Yeah. Now, you know, when you take like that, the answer of this fraction is equal to k. I can write that separately. Therefore, I can write logarithm of a divided by b minus c equals k. Second, logarithm of b divided by b minus c also k. Logarithm of c divided by a minus b also k. This we can talk. Understood? Right. Up to here, I think everybody can understand. Any question, people, up to here? Any question? No. Right. Now, secondly, what I do, people, you learn something like this. X divided by 2 equals 3 if you have something like this. To get the answer of this x, usual method is we can multiply both sides by 2. Left hand side and the right hand side we multiply by 2. Then the simplification takes place like this. This 2 and this 2 you can cancel down. X equals 2 multiplied by 3. The same thing we explain people without saying both sides multiplied by 2. We can explain that in another way using the cross multiplication to this thing. By this 2, we multiply this 3. And we write that on the right hand side. Then see, you get this, no? 2 into 3. Then x equals 2 into 3. Understood? Now people using that, here, by this b minus c, I can use a cross multiplication to write. By this c minus c, I can use cross multiplication to write. By this a minus b, I can use cross multiplication to write. Then we can take three relations. Understood? Then we get log a equals k times b minus c. Okay. I'll take this as equation number 1. By multiplying this, what do you get? Log b equals what? K times b minus c. I'll take that as number 2. Taking this way, people, cross multiplication, we get log c equals k times a minus b. Number 2. These three equations we can take. Right? Up to here, you can very clearly understand now. Okay? Right. Right. People come up to there. Right. Now, right. People now, suppose we have some equations like this. X plus y equal a, right? And then y plus z equals b. Suppose like this, we have two equations. Even these two equations we can add, that we denote by this two. These two equations we add like this. When you add two equations, the left hand side we add separately, right hand side we add separately. Then the two left hand side, this and this we have to add. X plus y plus y plus z is equal to adding right hand side a plus b. That way, two equations we can add. Now here to take the answer, these three equations we add. 1, 2, 3. The three equations we add together. When we add them up, we have to add them up how, people? Left hand side we have to add separately. Right hand side we have to add separately. Okay. Then we'll write that line. Let's simply write down like this. Now 1 plus 2 plus 3. Add this 3. This 3 we have to add. Log a plus log b plus log c. Remember, the base of the log term, people, base of the log term at this three places, the same positive value we have. The same positive value we have. Right. The same positive value we have at the basis of the log term. Right. Now on the right hand side, we add the right hand side. Right hand side, when you add k times b minus c plus k times c minus a plus k times a minus b we have. Right? I think up to you can understand. Now, see, this left hand side, you can write sum of the three log terms. Can remember, this is a formula we proved, a law we proved. Log, people, here, base a m min. We proved how? Log a m plus log a n. I think you can remember this. By extending this idea, we proved when there are four numbers here, the product of that four numbers and log you can write as a sum of four log terms. Today we, of course, recall that to work out the previous question. Here, people, when we have three numbers as the product PQR, that you can write log AP, log AQ, log AR. This way you can write it. What is the converse result? The converse result is therefore, when we have this way, sum of these three log terms, that sum of that three log terms, we can write as the product of that numbers available here, subject to log the same basis. Understand? Now, here also we have such situation. The bases are the same. Log terms being added. Then this sum of these three log terms, dear students, as here, we can write how? Write in log here, multiplying this number, ABC. Am I correct? So then we can write log ABC. We don't worry about the base, people, here. Right. Now on the right hand side, we can See people, here we have k, here we have k, here we have k. That k you can take out as common factor from the right hand side, right? Then once you take that k out, we open a bracket. Within bracket now we must write b minus c and the c minus c and the c minus c. Right? Huh? Now this within bracket, you can see a certain simplification we can do. What's that? B minus b, 0. C minus c, 0. A minus c, 0. Finally, people, this is 0. This is 0. Within bracket now we have 0. That 0 you should multiply by k. K into 0. When you multiply any value by 0, answer is 0. Then we get equal to the right hand side 0. Like this. We get 0. Then what do we have in the left hand side? Left hand side is this log ABC to a certain base. We don't know the base. It is not important to us. Whatever the base, we can take down. People now think like this. You know, we can write power 0 of a real number a. This a is not equal to 0. Power 0 of any real number which is not equal to 0, you know 1. We know 2 to the power 0 is 1, 3 to the power 0 is 1, 4 to the power 0 is 1. We know this, right? That people proved, no, under index law. Then here also, a to the power 0 equals 1, but that is important to mention this a not equal to 0. Because if a becomes 0, this becomes 0 to the power 0. 0 to the power 0 has no meaning. No meaning. 0 to the power 0 has no meaning. So therefore, you have to mention there a not equal to 0. Yeah. Now this is what I am trying to tell you. 1 equals 3 to the power 0. Then convert this to logarithmic form. What do we have here? The index form of 1 only here we have. How to convert that to logarithmic form? Write in log in the left hand side. Write in this number here. The right hand side base we bring as the base of log here. This is equal to 0. This value. Yeah. People, what is this result? The result, we can understand this way. If the number here we have is 1, its log value is 0. In other words, if a certain log value has the answer 0, then definitely the number here we must have should be 1. Understood? Of a certain log term, if its answer is 0, definitely this number here we should have is 1. Then people, see here, we got the answer of this whole log term as 0. Then what should be this number? The ABC place should be what? 1. That means this ABC product should be equal to what? 1, no? Am I correct? To get the answer as 0, the number here we should have is 1. Here we got 0. Then this number ABC product, definitely the ABC product should be equal to what? 1. Understand? So therefore, we can take the answer like that. Then we can write here the knot. After the knot, we can take the answer. Therefore, we can write ABC product should be equal to 1. This is how we take the answer. ABC product is equal to 1. Correct, no? Yeah. Right, no? Yeah. Take the answer, right? And the second answer asking in it. What is the second answer asking in it? A second answer asking in it, people, a to the power a multiplied by b to the power b multiplied by c to the power c. We have to prove this is equal to 1. A to the power a into b to the power b into c to the power c equals 1. We have to prove this answer. Let's see people how to prove this answer. Right. There also we use another method, another strategy like this. Right. There also we have some work to do. Okay. Rather than asking why do we do like this, how to think like this, we'll first do the question. Thereafter we will know to get answers. This kind of methods also available. Remember the method. Wherever then you get a similar question, suddenly you recall this kind of question I did in this method. Let's try using this method. Then people, we get the answer. That is how people, we improve our skills. Right? Okay. Now, the second answer, we start like this. Right. First of all, I am going to explain you the steps in getting the answer. First is this. The equation number 1. The both sides of this number 1, we multiply by a. Both sides of this number 1, we multiply by a. Right. This way. Equation number 1, we multiply both sides by a. Right? Then we must write here a and right hand side a here. You know, in smaller grades, you learn under axiom, when we have an equation, both sides of this equation, we can multiply by any value. Even after multiplying, the left hand side and the right hand side are still equal. Using that fact, I multiply first equation both sides by a. It is noted by this way. Equation 1, we multiply by a. It means the left and right both we multiply by a. Okay. Then what you get, people, when you multiply left hand side of number 1 by a, here we get a log a equal, for the right hand side, k and this b minus c, we must multiply by a. Then that a with which we multiply the right hand side, people, I write like this, a times k times b minus c like this. Okay. Understood. Now what I do next, people, in the left hand side, we can furthermore simplify like this. You have learned a certain log term like this. Log m to the power r to the base a. We learned this r we can bring before. And you can write it like this. R log am. You can remember that. You know now the converse of that. If the power is here, you can bring that where here. The power you can bring where here. But the converse, people, if this log has certain value before, you can put as the power of n. That's the converse. Then here people see the log term has a certain value before that. That is called as a coefficient. That you can keep where as the power of this a. Then once to bring this a where here, we get log a to the power a. And here we have a base. We said we are not going to worry about this base. Understood? So then we'll apply that. What do you get there? Log this a comes as a base power of this a. Log a to the power a equal. By this a k, we multiply this both b and c. What do you get? K times ab minus k times ac. Understood, people? Now I'm going to take this equation as equation number 4. Now another two more equations we supposed to take. How? Number 2 we multiply by b. Right? Number 2 both sides we multiply by b. And doing this same thing, we take our equation number 5. Next to that, people, third equation we multiply by c. Both sides we multiply by c. And doing the same thing here we did, we take the equation number 6. Then we will have another 3 equations, 4, 5, and 6. Fourth one I obtain, people, fifth one and sixth one. By doing this way, as I explained, give me that 2 equations. That's the small work today. We have to do. I'll give some time. Right. Start that. Okay. Now you can see the left hand side and right of number 2 we multiply by b. So what do you get? B log b equals b times k c minus k. This b I can bring where here. Log b to the power b. Now by this multiply this 10, this both. What do you get? KBC minus KAB. This is number 5. Right. Now number 3. Both sides c multiplied by c. C times log c, right? CK within bracket a minus c. Now we can bring this c where here. Log CC. Bring this inside and multiply. KAC minus KBC. Right now, KAC minus KBC is number 6. Number 6. Okay. Yeah. Now What we do next is, people, we add this 4, 5, 6. We add this 4, 5, 6. Right. We add this 4, 5, 6. We add this 4, 5, 6. Hmm? We add this 4, 5, 6. Right. The left hand side of this 4, 5, 6 first we add this plus, this plus, this equals the right hand side. This plus, this plus, this. Add them up, people. I will give another few minutes to take this out. And give me the result. Right. Once we add this 4, 5, 6, so left hand side we get this plus, this plus, this. Right now, log a to the power a plus log b to the power b plus log c to the power c equal right hand side. This three we have to write. AAB minus AAC and this KBC minus KAB KBC minus KAB plus KAC minus KBC. This what we get. This what we get after adding them. I think everybody could take this result. Yeah, now people, you can see the simplification on the right hand side. This KAB minus this KAB will be 0. This KBC minus this KBC will also be 0. This KAC minus this KAC will be 0. Then finally, the right hand side answer is 0. People, usually when we do the simplification, this KB minus KB 0, no? That we show by cancelling like this. Understand? This KB will cancel with this KB, KB minus KB 0. That way we denote it. Okay? And then this KAC minus KAC, this plus KAC. When simplify 0. Then both terms KAC minus KAC vanish there. To give that idea only, people, we cut like this. This also same way we can cut. And what happens? Right hand side answer is now 0. Okay. Left hand side here, you know, sum of three log terms. Sum of three log terms you can write in log term and multiplying with numbers available in log. What is that? A to the power A into B to the power B into C to the power C. This two. Now we have a certain base here. Now as before, people, now you can argue what? Logarithm to a certain base of this number 0. To get the 0 after getting log, people, definitely this number should be 1. Now this gives us A to the power A into B to the power B into C to the power C should be equal to 1. It's equal to 1. So this is how, people, we take a second now. See here the approaches. Right, people? See here the approaches. Little by little, the new methods we have to understand. Rather than saying we can't understand, difficult, people accept you. Most of the people, they say, when we do this kind of question, difficult. Those people never uh, do math. So very near future, they will change their stream. I don't think that here something like that. People don't take seriously new things we have to learn. They are so new sometimes. Due to this, of course, you get certain unfamiliar what situations your mind. Get rid of that form, that feeling, right? And try to familiar with this. Only thing is that try to familiar with new things, no. Try to familiar with this. Once you do this question, more new techniques, new method, more new strategies you will get. Collect them, understand them, remember them, then go forward. Then people, those things only you will use in the future again and nothing. Until you pick them, people, you have to be very patient and carefully study this. Don't be lazy. Don't think they are difficult, right? I think the people, they can patiently accept this, they will really win the game, right? So therefore, do the questions again and again as the same question, even never mind, do as homework, then you will familiar with that technique, right? Okay. To improve the math, people, we have to do. We have to do. We have to work out. We have to do again and again, again and again, again and again. Practice. Huh? Practice. Yes, that is how we do that question number 1. Yeah. Now, people, we will take question number 2 also. Question number 2, I'm going to take part A now. Let's do that also. Okay. Now go to people in your tutorial. Question number 2. Right. Question number 2, part A. Take. Question number 2, part A. Right. Then you are given logarithm x to the base 4 equals a. So logarithm x to the base 12 equals b. Yeah. Then people ask him to prove logarithm 4 to the base 3 equals b upon a minus b, and logarithm 48 to the base 3 is equal to a plus b divided by a minus b. Okay. Yes. Now we'll start the question like this. Okay. Now if I take this one, you know, dear student, log x to the base 4 is equal to 1 means really this left hand side denominator is 1. Right hand side denominator also 1. This is what this means. I think you agree with me. People, now see here, we know half is equal to 2 by 4. Right. These two fractions are equal. People, you know, when two fractions are equal, it is called as a proportion. That part we discuss next under basic math part in the same lesson. In that proportion, we have certain property. The property is this. Both sides, this number we can exchange this way. That is called as taking reciprocal on both sides. I think you have heard this word, reciprocal. Taking reciprocal on both sides, reciprocal. Even after taking the reciprocals on both sides, the resulting two values in the left and right are equal. See whether it is true. 2 goes up and 1 down. 4 goes up and 2 down. 2 divided by 1 is 2. 4 divided by 2 also 2. People still they are equal. Okay. Even here also, suppose this logarithm of x to the base 4, this has a certain answer, no? It has a certain value. Suppose, for instance, that value is 10, for instance only, this value is 10. This log x to the base 4 is 10 now. 10 divided by 1, 8 divided by 1. Then you can take reciprocal. Then what do you get? 1 over 10 equals 1 over 8. Using that, people, now I take reciprocal, both sides. Then this comes to down, this one goes to up. And then what do you get? Taking reciprocal, we can write. Taking reciprocal, you can write this comes to down, this goes to up. 1 upon log x to the base 4 is equal to 1 upon 8. Okay, right. Now, people, here to take this, I took the reciprocal of this. In taking the reciprocal, both sides we exchange the numerator and denominator. Both sides we exchange the numerator and denominator. Understood? Yeah. Now what I do, without changing the right, only this log term I take to numerator. There we can use, people, we learned one result. When we have log term like this at the numerator, you can take this log term to denominator by exchanging these values, A and B, and writing like this. We proved that kind of result. I think you can remember. Now that one I am going to apply. Now I apply from right to left. How? The log term this I bring to numerator. Then what happens? These two exchange. That's what this is. This one is different from reciprocal, taking reciprocal. People, when you take the reciprocal, you should have two equal fractions. So that's only we take reciprocal. How? Both sides we take, right? Numerator and denominator exchange. That is called as taking reciprocal. But that is what we did here. Now I am going to use the one property of logarithm. What is that? If we take a logarithm from numerator to denominator, the base and the number exchange. From denominator to numerator also, that two number exchange. That law only now I am going to use. Therefore, no reason to confuse you. Now you know now the difference, right? Now, people, I bring this only to numerator using this log law we learned. Understood? Fine. So then what do you get there? This two will exchange. This gives us logarithm of 4 to the base x. As equal 1 upon e. We get this as 1 upon e. Now this result is important to us. Right now? Yeah. People, can everybody give me, taking this Using this, give me this kind of result. That means an answer for logarithm of 12 to the base 6. Give me this result by following this way, the step for this, right? Okay. Start and give me that, people. Now here, this one I can take 1 over logarithm x to the base 12 is equal to 1 upon b. Now we'll take this to only this two numerator. Log 12 to the base 6 equals 1 upon b. This way we get that answer. Right. Right. Now I can write this logarithm 12 to the base 6. Logarithm 12 to the base 6 we can write, people. Right. This way. This 12 I can write 3 into 4. 3 into 4, 12 comes. You know, people, when we have a product between this 3 and 4 with the log here, this product we can write as sum of two log terms. How? 3 log base 6 plus 4 log base 6. You know, when you have a product like this, that product we can write as a sum. When you have a division here, we know that we can write as a difference. We did that theory. Loss we proved too. Yeah, then I can write logarithm base 6 log 12 to base 6. This one you can write this way as a sum. Okay. That you can understand. Log m into the base a, we wrote as log m to the base a plus log n to the base a. That way we wrote. Using that only I wrote this. Now substitute for this. Log 12 to the base 6, 1 upon b. Log 3 to the base 6. Only we need to find, people. We are supposed to find that. Keep that as the same. Log 4 to the base 6. Log 4 to the base 6 is 1 over a. Put that here. Understood. Now we'll take this 1 upon a to this side. Then subject it. I want to take this 1 upon a plus on the right hand side. Once we get left, it will be minus 1 upon b minus 1 upon a is equal to what? Log 3 to the base 6. Right? Now we shall simplify this. Here we have a difference of 1 upon b means a fraction, people. Here we have a difference of two fractions. Difference of two fractions we have. To subtract a fraction from another, we should have a common denominator. The denominators must be equal. If not, we need to find common denominator. When we have, people, this way, algebraic term as our denominator, our common denominator or the least common multiple of them we take as how? The product of this dn. Product of this dn. The present denominators we multiply to get the common denominator. For instance, suppose here, if I take, people, 1/2 plus 1/3. These are numerical values now. For this 2 and 3, you know the least common multiple is 6. Right? When you take this 6 as the common denominator, you know this 2 multiplied by 3 to take this 6. Then this 1 also, we have to multiply by 3. 1 into 3, 3 comes. This 3 should be multiplied by 2 to take this 6. Then this 1 also we have to multiply by 2. That's how we rearrange the numerator. People see certain results you can take by this. When you consider this 6, it is the least common multiple of this 2 and 3, no? The 6 we can find by directly multiplying this 2 and 3. Then, when our common denominator is the direct product of this present denominator, here 6 coming by 2 into 3, no? Then to find the new numerators, people, you can use this number, you can multiply with this one. 3 into 1 is 3. This is how we get this. By this number, you multiply this. 2 into 1 means 2. This is how we get this. Like that. When you simplify here, right? AB product we take as a common denominator. When we have algebraic term at the denominators of the fraction, common denominator we take as their product, like this. You know, as over there, people, whenever we take the product of this present denominators as our common denominator, the numerators can be found by using this same multiplication. A into 1 means A minus B into 1 means B. This is how people we simplify that. Now we get here log 3 to the base 6. Yeah. Now this equals, this means this equals this. So therefore we can write what log 3 to the base x is equal to A minus B divided by AB. This is not only we wanted to take. Okay, right. Now we can answer the first one. What is first one asking? Asking first one, people, logarithm of 4 to the base 3 equals this. That's what asking. Yeah, right. So come up to this. Yeah. Now people asking what? Now asking logarithm of 4 to the base 3 only asking. This answer only asking. Yeah, now I can use the change of base formula. Because now this logarithm of 4 to the base 3, I am going to write using change of base formula. How to write that? We use this change of base formula, no? Log, you must write at the numerator and denominator both. And now you must write here base of log we supposed to use. This time I am going to use base x, y. Subject to base x only, people. These two values we know. That is why. Right? Then here I write x. And here also x. Now what are the values here and here? Bring these two values 4 and 3 same way to the right at these places. This is how we use, how we apply the change of base formula. Understand? Now here we have log 4 to the base 6. Log 4 to the base 6 is 1 over a. That we can put here. Here, log 3 to the base 6, this one. Then that answer and this answer we can put here and here respectively. Therefore, we can write log 4 to the base 3, log 4 to the base 6. Log 4 to the base 6 is 1 over 8. Log 3 to the base 6, substitute for this space by this. A minus B divided by AB. This two, right? People, now let's see how to simplify this. How to simplify this? That simplification. How to do this? Yeah, that can be done like this. You know, here, when we have x upon y divided by a upon b, see here, x upon y divided by a upon b. This means you can write this one. This means really x upon y, this number should be divided by this a upon b. This is what really mean in the left hand side. I think you agree with me. This line means this divided by this, no? That's your formula. Now you have learned, people, when we have here division sign, writing that as multiplication, the next fraction you have to take reciprocal here. We write b over a like this. Now we multiply. Now we have a product of two what? Fractions. Two fractions we multiply numerator separately, multiply denominator separately. Like this. This is the answer. People, for the left hand side, here x upon y divided by a by b. For this fraction, the answer is this. Let's see how to take this answer without following this step. I can explain it like this. In the left hand side, this y and this a, when we consider, they are the closer ones. Multiply these closer ones together, and that product right below the line here, ay, here, y and a, ay. This is coming. The x and b are the further ones. They lie, all right, a little bit away than this y and a. Further ones, of course, people, we multiply here and write above the line. That is how we simply prove without using many steps. Now, people, you can apply that here. See here, once I apply that here, this a minus b and this a are closer ones. That closer ones we multiply and write below the line. A times a minus b here. Okay. The further one, this time, this one, they we multiply and write the product above this line. What is that? AB multiplied by 1. It is AB. Like this. Okay. Now, people, if you need, you can write this as a note at the side. This way. Now you can see here, this A and this AU cancel now. Here after cancelling we get 1 and 1. This is division. This cancellation means division now. Then we get B upon A minus B as the answer for this. Correct, no? That answer coming like that. B upon A minus B. Right now? Therefore, I can write that answer. Log 4 to the base 3 is B upon A minus B. Right, this note sometimes may be important, people. If so, you can write down that. Right. First answer is okay, no? Right. We'll do the second one also. Now the answer is asking no. Yeah. Asking the answer for logarithm 48 to the base 3. Right. I can write it like this. That answer we got log. You can then write the final answer. Therefore, log 4 to the base 3 equals b over a minus b. You see, we can take that. Now, second answer, logarithm asking 48 to the base 3. 48 to the base 3. Asking this answer, people. Log 48 to the base 3. I can write this 48 as 16 multiplied by 3. I think everybody agree with me. Logarithm 48 to the base 3, I can write. 48 you can write 16 into 3. Here you have a product. Then this right hand side, this product you can write as a sum. Sum of two log terms. What are the log terms? Log 16 to the base 3 plus log 3 to the base 3. That's how you can write. We'll write that. Log 16 to the base 3 plus log 3 to the base 3. This 16 I can write, people, 4 squared. Correct, no? 4 squared is 16. And this log 3 to the base 3. What is this answer? You know, when the base and this number both are equal, then the answer of that log is 1. That is 1. Now, next one, people, this 2 you can bring before. You know, this power you can take before. That also we have learned. Understood? Then write down that here 2 log 4 to the base 3 plus 1. People, the answer of this only we have found here. Log 4 to the base 3, b over a minus b. Then this b over a minus b you can put here. Substitute this b over a minus b where here and simplify. You get the next answer asking in the question. All right. After that, people start. Then here 2 this is 3 over a minus b. B over a minus b. Correct, no? B over a minus b plus 1. Now, people, how to simplify here? Here, this 1 has a denominator 1, no? Then for this a minus b and this 1, common denominator is a minus b. That is coming by the product of this and this. That way, if you think, never mind. A minus b into 1 means a minus b. Common denominator is a minus b. Right. Here 2 into this b means equal 2b. Its denominator also a minus b. The same denominator here we have a minus b. And so therefore, this numerator 2b 1 change plus People, what happened to this 1? You can see here, this a minus b means this a minus b here, when you multiply by this 1, we get this a minus b. That's why when you think, really, the product of this denominator and this denominator only, we have taken as a common denominator. That's the question I told you how to find the new numerator. I told you, by this 1, we have to multiply this. That we have already automatically written there. And by this, we have to multiply this numerator. A minus b and this 1, when you multiply, we get the same a minus b. Peter, when you multiply any number by 1, the same answer comes. So therefore, a minus b into 1 means a minus b. Here we must get a minus b. Now you can see here 2b minus b. It is b. And plus a here. Then what we get? A plus b. A plus b. Divided by a minus b. This is equal to what? This is equal to the left hand side, log 48 to the base 3. This is how people we take that answer. Right now?